Welcome back to another exciting chemistry lesson. In the previous lesson, we learned how to use a spectrometer to determine the concentration of any solution. Now, in this lesson, we are going to look at the possible errors that may occur and cause errors in our data. Well, first of all, we have this graph right here. This graph, we have absorbance versus wavelength. And right here, we can determine which wavelength that we need to use to measure a concentration to give us the optimal result. That is, give us the best result. So we can look at that right here. Based on this range right here, from 580 all the way to 610 nanometer, this would give us the optimal result in terms of measuring our absorbance. Now, if we are using wavelength down here, we're not going to get the best result because there is very little absorbance that's happening, okay? A common mistake when we try to generate this data is that we sometimes forget to set the absorbance to 0. Because remember, you have to compare the pure absorbance first and then followed by your solution. By setting absorbance to 0 when you did your pure solvent, basically what's happening is that by doing that, you now can focus on the salt use. Okay, basically it removes the solvent from the reading. If you did not do it, the reading will give us both the solvent and the solute, and therefore it messes up your data. And remember, when you're trying to measure the concentration, you are trying to measure the concentration of the solute only. Okay. Now let's look at this graph and talk about some of the possible errors when we try to generate this standard curve. On this standard curve, we have specific concentration that is known to us because we are going to make it, right? And you already learned how to make a solution already by using M1V1 equal to M2V2, okay? And followed by that, you would have the addition of water, okay, until you get to your desired mark. So review the video on how to prepare a solution from a stock solution, and this would be the same process. Now, since this is a known solution, what are the possible errors? And remember, we are trying to measure the concentration of the solute. So when you are using a spectrometer, if your cuvette, which is a vial, if that's unclean, if it's not clean, what you have there is additional particles in there. And that additional particle will make it more concentrated. So therefore, this will increase the absorbance. So this is one of the possible errors right here. As you can see right there, this right here will cause your absorbance to increase, because increase in A, which is absorbance, will also increase in concentration. Okay, so keep that in mind. Remember, A equal to ABC. This is your concentration, and this is your absorbance right there. So if we did not clean our cuvette, or we use a dirty cuvette, or if we add something extra to it, we will cause absorbance to increase. Now let's look at the other situation where absorbance would decrease or decrease absorbance, and that is when you add in more distilled water. So when you actually adding extra distilled water, remember water is H2O. Okay, if you having more water, it costs more. It causes the solution to be more diluted, which means less concentrated. So that is a possible situation where, in that case, you would have the data to have somewhere right here. So you would have an error where it is way below the curve, okay? And lastly, another common error is that sometimes when you look at the data table or you look at this graph, all of a sudden you have a decrease or increase of absorbance, and you don't know where it's coming from. So remember, this concentration are known to it. So the only possible situation is that you label the cuvette incorrectly, and that is sometimes you label this, right? You switch it. So therefore, of course, you will see this concentration here would have a lower absorbance when this one have high absorbance, which is not possible because remember, concentration is directly related to absorbance. So this is a very tricky one to find. It's basically when you have a random increase or decrease in absorbance, but the concentration is increased. So you shouldn't have that, because as concentration increase, you would have absorbance increase as well. So keep that in mind. So those are the common errors when we're using spectrometer. And one of the things we have to remember all the time is knowing how to make a solution. And the process is going to be the same for any situation, okay? And as always, if you have any question, please take a picture of your work, put in the form, and we will do our best to help you from there. And we'll see you next time on another exciting chemistry lesson.